Melt is on. Mountain glaciers are shrinking in the Himalayas, the Andes, the Alps, and in North America.
We only have 27 glaciers left out of the original 150 that were estimated to be here.
And scientists say the ominous picture doesn't end here.
The climate is literally spinning out of control.
Melting glaciers will lead to rising oceans and killer storms. And like the mythical Atlantis, American cities could be swallowed by the sea.
The Jefferson Memorial will be under 15 feet of water. I mean, water will go up to the outskirts of the White House.
Glacier Meltdown on Mega Disasters. Each day, 500 million metric tons of ice from the polar ice sheet are lost, perhaps forever. This alarms scientists because ice sheets cover nearly 1/10 of the Earth's land and contain 75% of the planet's fresh water.
The potential melting from the big ice sheets of Greenland and Antarctica, those are really the gorillas in the woodshed if you want to talk about problems. Far bigger than what we would get from a few glaciers melting. That's really a key for civilization in this century. What's going to happen to the ice sheets?
The same ominous phenomenon is taking place all over the world. The renowned snows of Mount Kilimanjaro are disappearing. The frozen currents of the Andes are drying up. And the glaciers in Montana's Glacier National Park are vanishing. This full-blown retreat of glaciers is the result of an overall warming trend across the globe. The world's oceans are heating up.
They've warmed very convincingly in the last 10 years. The climate system is changing, and it's changing at a rate that compared to previous decades and centuries is quite rapid.
And warmer seas mean rising sea levels.
As water warms, it expands. So warmer water actually takes up more volume and increases the sea level as well.
Scientists are predicting a rise in sea level of 1, 2, or even 3 feet by the end of the century. But if a significant portion of the polar ice caps melts, it could be much more.
It's not totally unrealistic to think that sea level rise could be maybe up to 10 feet between now and 2100. There's a lot of ice in West Antarctica. It's grounded below sea level, and it's inherently unstable. So we are concerned that it could slip away very rapidly. And this amount could raise sea level by 15 feet.
Low-lying coastal areas could be devastated. Entire island nations in the South Pacific could be swallowed by the sea. In Bangladesh, the rice paddies that feed millions of people could disappear under salt water. Untold numbers of these people could be displaced and become climate refugees. And some of America's great cities, Miami, Baltimore, New York, and Boston, may see their most expensive waterfront properties washed away. Even worse, warmer oceans will cause more intense tropical storms and hurricanes.
Hurricane is a heat engine. It's a monster that devours heat, and it gets it from the upper layers of the ocean. And so the warmer the ocean, the more heat for the hurricane to develop.
Melting glaciers could be the first sign of this impending environmental catastrophe. A glacier is a slow-moving river of frozen water, a tremendous accumulation of snow, compacted by the pressure of its weight and turned to ice.
it oozes very, very slowly under the weight of its own gravity. And that's the key. A glacier has to move in order to be called a glacier.
Some of these frozen rivers of ice move as fast as 2 miles per hour. During the last ice age, they carved entire landscapes out of rock. A glacial system may be as large as a continent, or as small as a tiny valley between mountains. Each year when the snow falls, new ice is added.
A healthy glacier is one that's getting plenty of winter snowpack and is not melting too much in the summer. Then it can maintain its mass, or can even grow.
These mountain glaciers have been here for more than 10,000 years. Today, scientists are monitoring their health on a day-to-day basis. They predict that every one of these glaciers will be gone by the year 2050. But the lifespan of mountain glaciers is short compared to the rivers of ice that flow off the polar ice sheets. Many of these are more than 500,000 years old. It is these polar glaciers that are even more crucial to the future of the planet. Just in terms of mass, the polar ice caps are astounding.
Antarctica is not at the human scale, it's huge. If you actually want to count all the individual glaciers in Antarctica, you're talking about tens of thousands of glaciers.
Difficult to get to, Antarctica, the 7th continent, was not even discovered until the 18th century. Since then, explorers and scientists have been trying to gather information about the polar ice sheets. In particular, they want to know how quickly the ice caps are melting, because this information can tell us how fast and how much the world's sea levels will rise. But the polar regions have remained elusive.
You have to realize that maybe 30, 40 years ago, we didn't even know where all the glaciers were, the important glaciers.
For decades, Greenland and Antarctica proved to be too huge to accurately survey.
What we relied on was putting together hundreds or thousands of individual measurements taken in the field by individual scientists going and visiting a polar ice cap and taking samples.
The complete picture of the polar regions and all their glaciers has remained an enormous jigsaw puzzle.
There's no way from fieldwork alone you could say anything about the entire sheet with certainty and with precision.
Now scientists say seeing the ice sheets in their entirety may be a matter of survival for future generations.
We really need to look at all of them, detect the areas where the changes are taking place, and keep an open mind that it may not just be 1 or 2 glaciers that are changing, but it could be a whole coastal range of several thousand kilometers which is changing at the same time.
These changes in the polar ice sheets and glaciers could spell disaster, and what these scientists discover could have a life or death impact on millions of people around the world. As the world's glaciers melt, the area of white reflective surface shrinks, replaced by earth or ocean, both dark surfaces that absorb more heat, which in turn accelerates meltdown. This is what scientists call a feedback effect. In the last 3 decades, 1/3 of all the glaciers in Glacier National Park in Montana have melted away.
Since the 70s, we've had pretty much a very rapid and full-scale disappearance of the glaciers.
Ecologist Dan Fagre has been monitoring their demise for 15 years.
Well, we use several ways of monitoring the glaciers. The first and most obvious one is that we take pictures. And these can be pictures from a point in the landscape, so you're looking at it from the side, and you can just look at the visual changes year by year.
Sequential photos taken decades apart show how specific glaciers have shrunk in size.
I can see with my own eyes how much that glacier has disappeared. And it's a little bit of a compelling and alarming kind of view, because you think about glaciers as being a steady presence on a landscape. And to see it disappearing this quickly means that we are going through some very, very dynamic times.
Here, Fagri is photographing Salamander Glacier, which has been losing mass rapidly. For glaciologists, the surface area is not the only factor that's important in determining a glacier's health.
There's also how thick it is, or how much total mass. And for that, we do a lot of ground measurements as well. And we can go on the glacier with global positioning systems and get both the area and the height. In this 1850 image, you see the glaciers covering most of the scene here. And the difference between 1850 and the present is that about 83% of the ice has disappeared.
The prognosis for Glacier National Park is dire.
Based on the best measurements that we have to date, it looks like the year 2030 is when most of the glaciers, if not all the glaciers, will be completely gone.
A similar fate is predicted for glaciers all over the world.
Almost all of the world's alpine, mountain, or valley glaciers have been receding. What's happening in Glacier National Park is basically going on globally. We're seeing that these mountains are being transformed by climate changes.
Melting glaciers have long posed a threat to local communities. Like many high mountain areas, the glaciers of Peru were once feared for the avalanches they unleashed.
You can have the situation where collapsing ice from a glacier will mix with volcanic material and creates a kind of a slurry. This is like liquid concrete moving at very high speeds. It's very, very devastating, and in certain spectacular situations has killed a number of people.
But now, melting ice has created a new kind of hazard. In the last 3 decades, the Peruvian glaciers have lost more than a quarter of their area. At some sites, ice has turned to water, forming high alpine lakes that threaten the villages below.
The glaciers actually have a dam that they have created, and as they melt, they fill up behind that dam. When the lake builds up to a certain level, it can burst out.
In mountain regions, glaciers serve as vital reservoirs for fresh water, providing 50% of the water nearby populations need.
When mountain glaciers disappear, there can be some real direct consequences for human beings. Case in point is some of these valleys in the Himalayas. It is the glaciers, particularly at the end of the dry season, that are providing the drinking water for people. So when those glaciers disappear, those people will have to find alternate water supplies, or basically have to move.
In the western United States, our dependence on glacial ice and snow reservoirs is just as great.
It's about 87% of the water that Americans in the West have to use. So mountains are very, very critical in providing that water.
A reduction in drinking water is only one of the problems caused by melting glaciers. Equally as troubling is what a meltdown of ice in the polar regions will do to sea levels worldwide. And the melting is occurring faster than anyone predicted. In 2000, scientists were stunned by changes at Antarctica's Ross ice shelf. The ice shelves act as buttresses for the glaciers, holding them back from the sea. Over the course of 2 weeks, a 4,247 square mile fragment, an area the size of the island of Jamaica, shattered and separated from the continent. 3 trillion tons of ice, the world's largest recorded iceberg, drifted out to sea. This recent loss of glaciers and polar ice is an ominous indicator of how quickly the oceans are warming up.
We're talking about several degrees warming over the next century, which is a huge number. The ocean is playing a very important role, and today we just don't have a good idea what's going on in the ocean.
But it's difficult to determine how fast the glaciers are melting.
The one major difficulty we have, the flow of glaciers is mostly controlled by what's happening at the bottom. And the bottom is the part that we don't see. The changes that we're observing in the ice sheets are more rapid and larger than what is predicted by the models. I think in the most extreme case, a lot of Greenland would be removed, a lot of West Antarctica, then you could raise sea level 10 times more than that, 30 feet.
A 30-foot rise means that many low-lying areas, such as large portions of Florida, would be submerged. Today, satellites are the most important tool that scientists have for monitoring what's happening to the oceans and the ice sheets.
To see the whole ocean, you have to do it from far away, and you really have to do it from space.
The satellites are able to do this, of course, because they're observing 24 hours a day, 7 days a week, 365 days a year, for years at a time.
During the last 50 years, several different satellite systems have transmitted invaluable data back to Earth. In 2002, NASA, partnered with the German Space Agency, launched a pair of satellites to help determine the extent of glacier loss. The Gravity Recovery and Climate Experiment, called GRACE, measures the gravitational pull of Antarctica and Greenland.
We took advantage of the fact that the same thing that makes you weigh on the bathroom scale, your mass, also causes a gravitational attraction that tugs on satellites in orbit. We wanted to put a bathroom scale underneath the ice sheets and actually weigh the ice sheets.
GRACE relies on two satellites, nicknamed Tom and Jerry.
And they chase each other around and around the Earth, about 100 to 150 miles apart, constantly measuring the changes in their orbit down to the level of a size smaller than a red blood cell.
These minute variations in Tom and Jerry's orbits alert scientists to changes in the distribution of water that covers the planet, whether in the seas and oceans, or in the form of ice in glaciers and polar ice caps. For 5 years, the satellites have been passing over the world's oceans and ice sheets, racking up a gigantic set of data. Every month, GRACE generates a new map of the ice that covers the Earth's surface.
If you look at what's the biggest change over the 5 years of the GRACE mission, you really see that changes in polar ice are things that really stand out.
According to images generated by GRACE, the picture is clear. The ice caps are losing weight, while the oceans are gaining weight. Scientists estimate from 100 to 200 billion metric tons of ice melt away every year. For those who studied these satellite signals, it's an alarming picture. Rising oceans will swallow farmland, towns, and cities. But, unlike floods of the past, once the waters have been unleashed, they will not recede. Rising global temperatures are causing a meltdown of the Earth's glaciers and ice sheets. If a sizable portion of the ice caps melts, the result could be catastrophic.
The big gorillas are Greenland and Antarctica. There's enough ice in Greenland to raise sea level by another 15 to 20 feet.
70% of the Earth's surface is covered by oceans. More than 1/4 of the Earth's population lives within 100 miles of a coastline. In the last 2 decades, many of these people have witnessed alarming changes. Once home to flourishing communities, low-lying lands are being eaten away by the sea. On islands in the South Pacific, residents have been fighting the encroachment of waves, devouring their shorelines. Tuvalu, an island nation 3,000 miles from Australia, is only 6 feet above sea level. With the seas rising as much as 3 feet by 2100, Tuvalu is in danger of being swallowed whole. In 2001, some of the leaders of Tuvalu conceded defeat in their battle with the rising sea and petitioned New Zealand to accept the island's 11,000 residents as refugees. Each year, a handful of Tuvaluans leaves, but others are staying put, wanting to call attention to the plight of their homeland. In Bangladesh, home to 150 million people, salt water from the rising ocean has invaded the freshwater rice paddies. Farmers have adapted by converting their rice plots into shrimp farms. But ecologists say that salt water has seeped into the drinking water. Without fresh water and rice to sustain them, it's possible that as many as 30 million climate refugees could be forced to find new homes outside of Bangladesh. In developing nations, this kind of mass dislocation could create havoc.
When mass populations like this move and the areas they live in are untenable, it could create health problems on a significant level. All these have security implications.
Retired Marine General Anthony Zinni has co-authored a report on the potential threat to national security posed by climate change.
We could lose access to resources in existing places that we depend on now, and that may create economic problems, and all this can generate conflict or challenge security interests we have, and therefore have a direct impact on the military.
Human beings don't like to migrate. They don't like to move their families and their lives across big pieces of territory. Put that in a world or a country that doesn't have resources, doesn't have transportation, doesn't have a federal emergency management association. It's a huge problem. Climate-induced migration could turn out to be one of the major sort of security issues of the 21st century.
Disturbing signs of warming are also occurring in the Arctic. In Alaska, areas of permafrost are thawing, releasing methane, a potent greenhouse gas, into the atmosphere. This phenomenon further accelerates the melting. With Arctic seas warming, whales, walrus, and seals are changing their feeding and migration patterns, making it more difficult for native people to hunt them. And while a dwindling food supply threatens the livelihood of indigenous peoples, a rising sea threatens to swamp their land. And farther south, a swelling ocean has been eating away the American coastline.
It's sort of a rule of thumb that if sea level comes up 1 foot, the impact will extend in to the coast about 100 feet. In places like the Gulf Coast, where the land is really flat, it can be 1,000 to 1.
Startling changes are apparent off the coast of southern Louisiana, where the land is very fragile.
You can go to South Louisiana today and the land is literally turning to water. Every day, 50 acres of land in South Louisiana turn to water. Every 10 months, an area of land the size of Manhattan turns to water.
But in other regions, the rising sea level is compounded by a natural phenomenon called post-glacial rebound. During the last ice age, a massive sheet of ice covered parts of North America. As the ice receded, land that had been weighted down by ice began to literally rise. Neighboring regions began to fall. The phenomenon is still at work along Chesapeake Bay.
The landmass that connects the Chesapeake Bay region and New England is like a giant seesaw. It's one piece of land. the land is naturally sinking a bit.
By the end of the century, land subsidence alone in the Chesapeake Bay region will add almost half a foot to the relative sea level rise. This may not sound like much, but a 1-foot rise could move the coastline at least 100 feet inland. Residents of Chesapeake Bay have already witnessed changes.
13 islands have disappeared, literally disappeared in the last 100 years. And the last inhabited island in Maryland's portion of the Chesapeake Bay is disappearing at an unbelievable rate.
One longtime resident of the region is former Marine Donald Willey. Willey has watched as the sea swallows Hooper's Island. He is fighting to save the island's one remaining legacy, an historic cemetery.
My family has been here since before the Revolutionary War. My goal here is to try to stop this erosion and protect this graveyard for as long as I can.
Within a span of 9 months, he's witnessed significant changes.
Just since last June, there's been about 25 feet has washed away back here.
For Willey, the cemetery is emblematic of so much that has changed in the landscape that he calls home. Gone are not only the homes of longtime residents, but also the protection that barrier islands once afforded this region.
If we get a bad hurricane, all this work that I've done here is going to go out in the bay, and probably half of these graves as well.
When a hurricane approaches the mainland, barrier islands act as natural speed bumps, slowing the force of a storm.
Even if the water rolls over the barrier island in a hurricane, a considerable amount of the energy is dissipated as the water passes through the trees and the vegetation.
The waves are further slowed by wetlands.
The water goes into literally billions and trillions of blades of grass, the friction of which disperse the water further, so that by the time the surge gets to serious population centers of human beings, it's been dramatically reduced.
But now, the barrier islands and wetlands are disappearing. Without the protection of wetlands and barrier islands, great coastal cities such as New York, Miami, and Baltimore will be helpless against the onslaught of rising seas and killer storms. As the climate heats up, ocean temperatures also rise, carrying us a step closer to disaster.
It's pretty certain that storms will become more intense. And this is because as water warms, the fuel for hurricanes sort of becomes higher octane. So the warmer waters will create more violent storms.
The greatest danger posed by hurricanes is from storm surges. In the United States, 90% of the people who've died in hurricanes have been killed by storm surges. When a storm surge is accompanied by a high tide, it can raise water levels 15 feet or more and reach a mile or more inland. Throughout history, inhabitants of low-lying coastal regions have developed various ways to protect themselves from storm surges. In Holland, where much of the coastal plain lies below sea level, residents engineered a remarkable system of dikes and levees to hold the North Sea at bay. Windmills functioned as pumps, keeping the countryside dry.
The Dutch really perfected the technique of using levees in the Middle Ages and have subsequently just built upon the levee system.
But sometimes a pounding sea overwhelmed even the strongest defenses. In February of 1953, gale force winds and exceptionally high tides breached the dikes. The flood came in the night without warning. Waves destroyed 300 Dutch farms, 3,000 homes, and left more than 1,800 people dead. In England, a rising sea has been threatening the city of London for nearly 5 decades. In 1984, engineers erected the Thames Barrier, a flood control structure on the Thames River downstream from London.
This is sort of a temporary gate, that's a door that's shut when this big dome of water starts to approach the city. It's opened and closed 80 times since it was completed in the early 1980s.
Before 1990, storm surges caused an average of 2 closings per year. Since 1990, the closings have jumped 100% to 4 per year. North American communities have also been vulnerable to storm surges. During the 20th century, 167 powerful hurricanes slammed against America's Gulf Coast and eastern seaboard. But of the 6 most powerful storms to strike America, 3 of them happened in the span of 52 days in the year 2005. Wilma, Rita, and Katrina. And experts warn that Katrina may be a harbinger of things to come.
What's of concern as a disaster science specialist is that many communities are not taking the Katrina lesson to heart. And there's always that attitude, it won't happen to me.
According to the Intergovernmental Panel on Climate Change, the global warming partially responsible for these more severe storms was triggered during the Industrial Revolution in the mid-19th century. As factories began to burn fossil fuels, millions of additional tons of carbon dioxide, the greenhouse gas, were released into the atmosphere. CO2 is very effective at trapping the Earth's heat.
Think of it as a blanket. CO2 intercepts some of the outgoing radiation from the Earth and traps it and then re-radiates it back down at us.
During the 20th century, the world's temperature increased by an average of 1.1 degrees Fahrenheit, much greater than in any of the previous 9 centuries. The rise correlates with the increase in fossil fuels that are burned by industrialized nations each year. And this rise in atmospheric temperature is followed by a rise in ocean temperature. But how much and how quickly the ocean is warming has been difficult to measure. Just as scientists have found with the polar ice caps, obtaining accurate temperature measurements of an area as massive as an ocean presents a daunting challenge. Until recently, independent measurements taken by researchers sailing the ocean on ships were haphazard and couldn't provide a global picture.
We've got a few gaps in the coverage up here.
A new international project known as Argo is now providing a more comprehensive view.
The Argo project is designed to measure the physical state of the oceans. And by the physical state, I mean the vertical structure of temperature, salinity, and ocean current.
To date, nearly 3,000 Argo floats have been deployed throughout the world's oceans.
Well, we have enough now that we feel we can really observe the global ocean at the level that it needs to be seen.
Argo data indicates that the oceans are warming at an alarmingly rapid rate. For low-lying coastal regions, this warming trend could be devastating. In the U.S., the Gulf Coast and especially New Orleans are at extreme risk.
I think it's the most dangerous city in the world to live in. Katrina, too, is inevitable because we failed to learn even one lesson from that hurricane, and that is rebuild the levees, rebuild the wetlands and barrier islands, and stop global warming. We're not doing any of that.
With an eye toward the future, Scientists have attempted to predict what a 3-foot rise in sea level would mean for some of our cities. To illustrate the impact that a hurricane might have, an engineering firm called Applied Science Associates has generated computer visualizations of a Category 2 storm. The U.S. Geological Survey supplied data on the elevation and topography of each city. The National Hurricane Center provided its sea, lake, and overland surges from hurricanes, or SLOSH, model results to determine the maximum storm surge elevation as it floods cities along the coast.
Anybody who feels safe even watching New Orleans disappear as a viable city should not feel safe because your city could be next.
In New York, a Category 2 storm could cause a 17-foot surge, flooding much of lower Manhattan, including Wall Street and Ground Zero. In Boston, such a storm could generate a 14-foot surge, submerging much of the historic North End and Financial District. And in Miami, just a 3-foot surge would inundate Key Biscayne, South Beach, and Miami Beach. In addition to these great coastal cities, Washington, D.C. is also threatened.
One of the best kept secrets of global warming is that the nation's capital, Washington, D.C., is extraordinarily vulnerable to changes in our climate, especially in terms of sea level rise and more intense hurricanes.
Although Washington is nearly 100 miles from the coast, its unique topography puts it at risk. Once a marshland, parts of the tidal basin and mall are only 6 feet above sea level. But what makes the city even more susceptible to ocean storms is the Potomac River.
The Potomac River is a wide, flowing river that actually has tides because it's connected to the bay, which is connected to the ocean, which means that if you get 1 foot of sea level rise worldwide from the oceans, you get 1 foot of Potomac River rise in downtown D.C. If you get 3 feet or 23 feet or 80 feet of ocean rise worldwide, you get that much in Washington, D.C.
With temperatures rising in the mid-Atlantic, this entire region is at risk.
Scientists say, well, we could get 1 to 2 to 3 feet more sea level rise this century. Then you're starting to look at some very serious impacts for the nation's capital.
Surface temperatures above 82 degrees could turn Category 2 storms into Category 4 or 5 hurricanes. Physicist Min Lee has done a hypothetical calculation for what such an intense storm would mean for the region. His projections are based on the behavior of Isabel, a Category 2 hurricane that lashed the Chesapeake Bay in 2003.
We have done a very preliminary calculation, assuming that if the wind stress would be double that was experienced during the Isabel, then the storm surge that expected at Washington, D.C. would be 5 meters, at Baltimore would be 4 meters, would be twice as high as it was recorded during Hurricane Isabel.
In other words, a Category 4 hurricane would submerge low-lying areas of Washington under more than 15 feet of water. And as glacial melt increases, the global threat from storm surges increases. Each day, data sent by satellites adds to our understanding of the big picture.
There are literally thousands of scientists, hydrologists, oceanographers, glaciologists that are taking those maps of ice mass changes, of ocean circulation changes, and interpreting them.
And of course, the most important question of all persists. What can we do to slow this ominous warming trend? And will we be able to respond in time to avert a global catastrophe?
It's easy to dismiss it as a 20 or 30 year out problem, but there are certain things that if they're not done now, we will not be prepared. We're going to lose the opportunity, for example, to mitigate against the effects or to prepare ourselves for the effects.
These experts are pushing for more aggressive cuts in emissions of greenhouse gases. But even if we make the needed reductions, most greenhouse gases take a very long time to leave the atmosphere. During this time, the oceans will continue to warm.
If we were to stabilize greenhouse gases today, right now as we speak, the ocean would continue to warm for probably at least 30 to 50 years, maybe longer.
Warmer oceans and the rise in sea level caused by melting glaciers and polar ice could create a worldwide disaster. One day, in the not-so-distant future, rising temperatures could propel us toward a mega-disaster. The glaciers in Montana have vanished. The mountains in the Himalayas, the Andes, and the Alps are bare of ice. And we've lost 5% of the Greenland ice cap and 8% of the West Antarctica ice sheet. Average sea level worldwide has risen by 3 feet. Already, cataclysmic storms have battered several American cities. The loss of wetlands has made New Orleans defenseless against even the weakest storms and subject to persistent flooding. Sections of Miami have been deemed too vulnerable to rebuild. Lower Manhattan is a sodden disaster zone. And a warmer Atlantic Ocean continues to breed severe tropical storms. In our hypothetical scenario, a hurricane is building over Cape Hatteras, heading for the Carolina mainland. The storm is a monster in the making. The wind shear is low, and the eye wall forms a nearly flawless cone of clouds, some 60,000 feet high. In the eye wall itself, winds whirl at 230 miles per hour, lashing the Cape Hatteras lighthouse. Further to the north, residents of the Chesapeake Bay region brace themselves for the worst.
Well, the areas that are very vulnerable to being flooded are, of course, all the coastal cities right on the main part of the bay, Annapolis, the upper part of the bay, Baltimore.
Some residents have experienced a Category 2 hurricane, but before today, a Category 4 has not hit this region.
If we have a Category 4, you have to square the energy that goes into these things, so you have 4 times as much energy.
Meteorologists warn that the hurricane will make landfall by early the next morning. At 4 a.m., the storm churns into the mouth of the Chesapeake Bay at high tide.
It's got a lot of maneuvering room, and especially if it has a small eye, you're talking about a hurricane in the middle of the Chesapeake Bay that's behaving as if it's in the middle of the Atlantic Ocean.
The surge, now a gigantic mound of water, curves up the western shore, wreaking havoc on the town of Havre de Grace.
Nothing slowed it down. It's built right into the bay. No barrier islands, no wetlands.
Waves are whipped into a frenzy, smashing everything in their path. Houses are broken and scattered like so many matchsticks.
That would be probably your worst case scenario for doing the most damage as it went up the bay.
The storm lingers near the city of Harrisburg, Pennsylvania.
Probably have quite a bit of wind activity that could drive the waves, so you'd have a lot of damage.
Residents of Baltimore and Annapolis, Maryland's capital, are ordered to evacuate. People panic. Rising waters have erased long stretches of pavement. Only 4 exit routes remain intact.
You would be following a massive evacuation over 4 bridges. I can't visualize that we'll ever be able to evacuate a huge number of people.
At 9 a.m., the storm heads up the narrow estuary of the Potomac.
It hits the main stem of the Potomac River, and the water is funneled into a narrow area, and it has nowhere to go but up.
By now, in Virginia, parts of historic Alexandria are underwater. The surge builds. Washington is almost 100 miles upstream from the mouth of Chesapeake Bay, but it is still very vulnerable.
It's going to cause the surge to be channeled into a narrow area, which will cause it to rise and cause it to move faster toward the city.
By the time the storm reaches the city, it is a wall of water.
That might give us as much as 15 or 16 feet at the heads of these tributaries.
Waves sweep over the runways at Reagan National Airport.
National Airport is low-lying. And parts of National Airport is reclaimed land. The whole airport is right at sea level right now. It's right at sea level.
The surge pummels buildings on the National Mall. In the tidal basin, the water keeps rising.
You're talking about a city that big parts of it are just don't have a lot of elevation. It's a city that has many portions of it that are extremely vulnerable. Water will go up to the outskirts of the White House.
When the storm finally subsides, parts of Washington are sitting under 15 feet of toxic water. This image of the nation's capital is a symbol of what many of our great cities could become.
Unless we put the brakes on fossil fuels soon, it's going to be a city below sea level, surrounded by levees, hit by bigger and bigger hurricanes.
According to the Intergovernmental Panel on Climate Change report, this could be the future. Coastal cities on every continent at risk. Tens of millions of people displaced, with dwindling supplies of fresh water and food. All potential victims of what many experts say could be a global glacier.